right, work, power, and energy, part 2. Okay, so this would be our second part, and we now have done work and power, and we'll start talking about our energy basics. Okay, so energy is the ability to do work, or that which can be converted into work. And there's lots of different types of energy. We talk about kinetic and potential energy, and potential energy can be anything like stored mechanical, which we talk about, and gravitational potential, which we talk about. Nuclear and chemical, we don't talk about those so much in this class. That's in my AP2 class. And then kinetic energy, we talk about movement primarily. Thermal, light, and electrical kinetic energy are primarily discussed in my AP2. But there are those various types. Now, when something has energy, it is able to perform work. So in a general sense, to change some aspect of the physical world is to do work. Okay? So in mechanics, we're concerned with 2 types of energy, and those 2 types of energy are kinetic energy, which is the energy of motion, and its formula is K equals 1/2 mv squared, which is on your formula chart, and its units are joules. Since kinetic energy is really just a form of work, it has the same units as work does. The other one is potential energy, which on your formula chart is listed as U, and its energy possessed by just its position or its condition. And for gravitational potential energy, we'll have mass times gravity times height. And again, its units are also in joules because it's really just a form of work. All right? So really the thought process is we have kinetic energy, and it can be converted into kinetic energy, or we have potential energy that can be converted into kinetic energy, but really overall the amount of energy stays the same. So for most mechanical systems, or for all mechanical systems involving conservative forces, which we'll talk about those in a little while, the total mechanical energy equals the sum of the kinetic and the potential energies of the objects that make up that system. So the sum of the kinetic and the potentials will be the total mechanical energy. All right? And for this one, you can see that it's always 100. So if it switches, then they add up to 100. All right? So that's all we're going to talk about for that portion. Most of this is calculation problems that we're going to do in class, so we can discuss the conservation of energy and the calculations of kinetic and potential energy. All right, make sure you've gotten this in your notes.